Take a furniture warehouse, about 15,000 square feet. The operations team decides to install a few security cameras to monitor the docks and staging lanes. On paper, it looks like a standard hardware addition, but the moment those new cameras power on, the workflow stops. Without warning, daily operations grind to a halt. Down on the floor, forklift drivers lose their connection to the warehouse management system. In the aisles, barcode scanners lag out, leaving workers waiting for loading icons to clear. This happens because the warehouse was relying on a basic internet setup. The business operated on the assumption that total square footage was the only metric that mattered for Wi-Fi performance. Plugging in high-resolution Power over Ethernet cameras pushed this unmapped system past its data limits. The new video feeds immediately overwhelmed the available bandwidth. A camera installation acts as a stress test. It forces every hidden weakness in the warehouse's operational infrastructure to the surface. To understand why basic wireless fails rugged scanners and mobile tablets, we have to look at how the physical environment itself treats a signal. A furniture warehouse is filled with signal barriers. Metal pallet racks bounce radio frequency waves in unpredictable directions, while boxed sofas, dining tables, and thick mattresses absorb the energy. An RF site survey identifies dead zones. By mapping the layout, engineers guarantee a consistent signal strength of -65 dBm along critical picking paths. This mapped signal ensures forklift tablets maintain a steady connection as they navigate the maze of dense inventory and racking. While the scanners rely on those wireless pathways, the new security cameras require a wired connection for data and a specific amount of electrical power. This equation breaks down the Power over Ethernet, or PoE, requirements. 6 access points and 16 cameras create a baseline load of 342 watts. Adding a 30% reserve buffer brings the necessary capacity to 445 watts. Calculating this exact PoE budget and running Cat6a cabling prevents the network switches from overloading. Without this planning, switches can fail or cameras can randomly shut down during peak activity. Managing the physical reality of a warehouse means mapping invisible radio pathways and mathematically guaranteeing power delivery before any hardware is mounted. Beyond the physical cables and signal waves, we must look at the digital flow of data. Most failing networks share a common flaw. They are flat. In a flat network, every connected device, from office laptops to warehouse scanners, shares the exact same unsegmented digital space. This creates a chaotic traffic environment. A guest connect in a smartphone in the showroom occupies the same digital space as the high-bandwidth security cameras and the critical inventory scanners. To resolve this, engineers use virtual local area networks, or VLANs, to implement network segmentation. A VLAN drops digital walls into the network. This organizes the traffic into dedicated, parallel lanes that remain completely separate from one another. This segmentation prevents a compromised device in the guest area from moving laterally to access the camera server or the inventory system. It also ensures that a surge in guest traffic won't starve the scanners of the bandwidth they need to function. Network security depends on this architectural isolation, keeping critical business operations physically and digitally protected from outside traffic. With the engineering complete, we can look at a right-sized network in full operation. The cameras operate securely on wired PoE, while the barcode scanners maintain stable connections in the staging lanes and dock areas. Guest traffic in the showroom is now isolated in its own digital lane, making it invisible to the core warehouse operations. Curious, observant. However, a warehouse is a dynamic physical environment. Watch how the space changes. Racks shift, inventory fluctuates, and dock doors are in constant motion. Seasonal volume spikes change the amount of material in the room, while new staging areas, or IoT sensors, can introduce fresh variables to the network. These inevitable changes mean a network must be continuously monitored and audited to ensure its performance doesn't degrade as the physical environment evolves. A camera installation is the moment when a business must evaluate its underlying infrastructure. By designing for the actual physical and digital requirements of the space, the network can finally handle the heavy lifting of the daily workflow.